So the agenda for today is motivation. Why did we build the REST API? What does it help us to achieve? Evolution. How did the Performance Center REST API evolve over time and over Performance Center versions? Then we will do a functionality overview followed by actual code examples, some of which can turn out to be very useful, and a demo on starting a test run through the API. Finally, we will cover the use case of using on-demand Docker container load generators to run our test, and we will see how to leverage this ability to run a load test when there are no available load generators in the system. So, why did we build a REST API within Performance Center? First and foremost, the most important reason is to enable DevOps with Performance Center by supporting automation processes that need the performance testing to be part of their pipeline. Second is CI plugins. We wanted to create a single common interface to be used by all CI plugins. As some of you know, Performance Center already has a public, state-of-the-art, open-source Jenkins plugin that is using the REST API. And we have future plans to create plugins also for other popular CI tools like Bamboo and also TFS and TeamCity. All these plugins will be using the same API. Another good reason to build the API was to basically allow our customers to tailor their usage of Performance Center to their own needs, and not necessarily from the traditional Performance Center user interface. For example, if someone wants to show the results of the last test run on a dashboard or any other information from Performance Center without the need to log into the system, the API allows to do that, while in the product itself, we can never allow it due to obvious security requirements. A few notes about the implementation. Performance Center REST API is totally stateless. This means that if you have a few PC servers in your environment, it doesn't matter which one of them will get called. Any one of them will return an equal response. This allows the usage of load balancer in front of the PC servers, also when using the REST API. Secondly, when building your REST client, as far as we are concerned, you can use Java, Scala, .NET, Ruby, Python, or Node.js, and basically it doesn't matter which technology you use. As long as it meets the REST common standards and it is written with accordance of the Performance Center REST API documentation library, it will work equally good. Finally, when we designed the API, we tried really hard to make the URLs as easy to understand and intuitive as possible, at least in the main pass use cases. This slide here articulates the evolvement of the functionality and usability in the REST API over the various Performance Center versions. The first version of the API was introduced in version 12, in which we basically provided the most minimal capabilities that allow running a test and getting the test results using the REST APIs. Over the various releases, we continuously enhance the capabilities. However, in version 12.55, there is a major step forward in which we introduced a lot more capabilities, which I will elaborate on later. As you can see, in 12.56, we are enhancing even further, and our intentions are to continue enhancements in this area, also in future versions. So we approach to you, basically our customers and users, to come and raise as many requests and things that you have in mind regarding the REST API. This is an area that we will definitely continue to invest in, and we would like it to be customer-driven as it was so far. I would like to take this opportunity also to thank a few of our customers who used as design partners, and thanks to the close contact that we had with them, we've managed to basically target the most meaningful use cases. Now, the API is split into two main areas. There are use cases that are more meant for performance testers, and use cases that are more targeted for lab management and administration purposes. The use cases that you are going to see in this slide are basically more project-driven and more oriented for automating the work that the performance engineer is doing on a day-to-day basis. The first and obvious functions are authenticate and logout. Then you have the ability of getting the project's hosts, adding a host to a project, and change a host's details. As you can see, a few of the items were added only in version 12.55. Like, for example, the ability to upload the JMeter test. So you can upload the JMeter test. You can associate the test to a larger performance test, where you can also have Vusion scripts, and then run it, of course, and get the results downloaded to you. This can be very useful for automating the process of agile teams that are not necessarily familiar with the Performance Center, but can still benefit from the performance testing, reporting, and analysis capabilities that Performance Center brings with it. And this can be done without even interacting with Performance Center user interface, so you don't need to worry about people who are not familiar that needs to be taught how to work with the product. A few more enhancements that are really nice, and those of you who are using the API more extensively will probably appreciate. You can assign runtime settings for several scripts in one bulk. Basically, it's kind of a shared runtime settings model inside the definition of the test, while using the API. Same applies for command line. Also, the entire trending application was exposed almost completely in order to allow you to get all the trend data, as well as in the test configuration itself to turn on the automatic trending using the REST API as well. So, you can see the coverage is pretty wide, and you can do a lot of it. You will see some more examples shortly. When it comes to the lab management use cases, all of that is actually brand new. It didn't exist in earlier versions and was introduced only in 12.55. The main benefit of these APIs are that you don't need to log into each and every project individually, but rather access the data across all projects in a single query. Whether it is about the test runs, the hosts, host pools, and even projects, and you can do various different operations, both in order to manage the environment and also in order to start a use case in an easier way, and maybe even continuing that later on in the project. Now, I would like to move on to some code examples. Of course, everything will be shared with you. I'm going to touch a few code examples. Later on, when we send the deck and all the materials, you will get more than that, just because I cannot talk about everything in this scope due to time constraints. So let's see some of those code examples. So the first and most obvious example will be authenticate, written in a C# language. Let's go a little bit through the code. Here you can see the URL that is used for authentication. The 0 in the beginning marks where we need to plant the name of the Performance Center server or IP. So after we assemble the URL with the PC server name, we create an HTTP web request object, which is a standard .NET object. Then this piece of code here takes care of the credentials needed to authenticate. Now, in order to authenticate, you need to add to your request an authorization header, where its value will be basic, space, and then a string which is assembled of a concatenation of the username and the password and a colons between them, and this concatenated string needs to be encoded to base 64. So this is the .NET standard way to encode to base 64. Every language has its own standard method. You can also find some free tools on the internet to do this for you. And after we add the header, we are good to execute the request. Below here, we have a code example that shows how to perform such a request using .NET standard library objects. Now the same example in Java. Also here we can see the URL, the same URL assembled with the PC server or IP. We create an HTTP GET request with the URL, adding the authorization header with the correct basic space and encoded concatenated string, and then we execute the request. Also here we're using only but standard Java library objects. Now to a little bit more interesting example. This example here is getting a list of all scripts inside a certain Performance Center project and downloads them to a local folder one by one. So let's go over the code. In the first line here, we assemble the URL. The URL is composed of the PC server name or IP, domain name, project name, and the postfix scripts. This means that we want the list of all scripts inside this project. Now, the response to this request will be an XML formatted list of scripts data. And this is how it will look like. We will have a list of such scripts. Now you can see we have numerous parameters for each script. We have its ID, its name, its folder path inside the Performance Center, its protocol. Now I'll get back to the code. Here we take the response, which is, as I showed you, composed of a list of script metadata. And we take all the tags that contain an ID. Actually, we're iterating through all IDs in the response. Each ID is parsed into an integer, and then for each script ID, we're assembling requests that will download the zip file behind it. You see this URL here is similar to the previous one, but instead of just referencing all the scripts in the project, it references a script with specific ID. This is where we plant the script ID, and after it, the postfix zip. So this means we want the zip file behind this script. Now, in our example here, the script ID would be 8. Yes. Now, if you take a further look into this code here, you can see that we're saving the zip file we named as the script ID.zip. So in this case, the file will be called 8.zip. Now, you don't need to worry about the naming here, because when you upload this script back to Performance Center, it will get back its original name, which in this case would be login logout page. So I'll let you have another glimpse at this example. This is where we write the response to a file. And moving on. So now we're going to see a demo of running a load test from the API. And I'll also show you that it's exactly the same as running the load test from the Performance Center user interface. Now I will start my application in the background and we'll go over the code. So first I did an authentication to Performance Center and then sent a REST request to create the run entity. Actually create a new run. So I'll wait for the run to get into initializing, to be created and get to initializing state. Oh, here it is. We can see it inside the UI as well. And now go over the code a little bit. So here is the URL for creating a run. You see it's composed as normally as from the Performance Center server name, domain name, project name, and the run's postfix. Here in the request body, we need to state which post-run action we want, what is the test ID, test instance ID, time slot details, and what's important here is the request needs to be sent with the HTTP method of post. Now, once the run is created, it is returned, the whole entity is returned, and we can get its ID. Now, once you have its ID, you can you can start polling for its state. You see the run got into the running state. We can see it also in the UI. Same way, we can also view its run screen. Now here we're polling the run state. You see we have a URL here that goes to this specific run. In the end is the run ID. Now, as long as we don't have a timeout, we send this request, and from the response, we just fetch out the run state to see what is the current state of the run. There are various other parameters that you can poll. Here is the online screen for this run. Now we'll wait for the run to end. So here it is ended and started collating results. We can also see it inside the UI. The run ended and collating results has begun. Now once the collate is finished, analyze is started. And here it's worth mentioning that through the API you can also set the analysis template to your test through the test definition. It also has a REST API, and if you do that, once you create the analysis data, it will be created according to your analysis template. Now, when analysis is finished, you can open the HTML report, the same as you can do with any other test run that you have in your system, just to emphasize the point that there is no difference between a run that is started from the UI and the run that is started from the API. Okay, now moving on. Suppose that you also you did your test run from the API, and now you also want to download your HTML report of this run from the API as part of your automated process, perhaps. So some background explanation on this method here. As some of you probably may know, each test run has a set of results behind it, like the raw results, the results.zip, and the HTML report folder, which is also zipped. Now you can use the API to iterate through all the results that are behind a certain run, and you can query its metadata to understand which result it is. So if you do that and you find the result that represents the HTML report for your run, you have its result ID. Now, once you have the result ID, you can compose here a URL that is basically assembled from the HTTP : and the PC server name /lotus /rest /runs, and then here you will have the run ID. Results, which means you want the results of this run, and here we plan the result ID, and with the postfix data, which means I want the data, the file behind this result. So once I send the request for this URL, it's a GET request. The response will be the file itself. I can write it to a file. Also here I'm using only standard Java library objects. And after that, it should be pretty easy to write a code that opens it also, in case we want. So this concludes the download HTML report example. Move on to another example. So this example here is taken from the part of the administration side. Now, the use case here is to simulate a situation where maybe we want to monitor our performance center environment and create such a process that will take all runs that are older than something and delete them from the system. And once I delete a run, also the results are deleted from the server, and by that save space on the ALM repository. So here we see the URL that is used to get all the runs. Now, something to note here, you can see this is from the admin part, and what's nice about this is that this query will go over the runs across all projects in your system. So you don't need to log in to each project and take the runs from there. It's one query. You have the query here. You can see how we set the filter of getting all the runs that their end date is less than something, some date, and after that, the response will come as a list of runs, as we saw earlier with the scripts. It will come as a list of runs in XML. Now, here I used an XML document, but it's pretty easy to create also objects that will be that this XML will be serialized to, and then you can treat it more object-oriented if you wish. Now, once I have this list, I want to iterate through all run IDs that I get. For each ID, I parse it into an integer, and then here I assemble a new request that will delete the run. How do I do this? So here is the URL. It's pretty similar to the one that we saw before, but here we don't have a query. It's just a run with a specific run ID, and the HTTP method is delete. So this will delete the run, and later on also delete the resources in the result files that are represented by this run. So with this example, this concludes this part, and here I would like to invite my colleague Albert Binaev to present the use case of Dockerized load generators.
Hello, everybody. Oren, thank you very much for the REST API introduction and demonstration. My name is Albert, and nice meeting you all. It's really exciting to realize that such a great amount of you, of our customers, are actually interested in that topic. As Aaron mentioned before, in upcoming 20 minutes, we are about to go over a very interesting and I think very valuable topic, a detailed example of REST API usage with Dockerized load generators. I am certain that most of you at least heard or some maybe even using Docker containers in your environment. That is yet another virtualization technology. Docker containers is the current trend in the CI and DevOps world, as you know. Of course, there are pros and cons for each type of virtualization system. I mean, in traditional virtualization system using VMs, you have a highly isolated system, costs you licenses, spin-off time, resources, etc. Using Docker container technologies, it's a bit different. Since you are using the same hosting machine for several Docker containers, you actually have a safe budget in operating system licensing, in maintenance, eliminating one of the virtualization layers. Think about time spent for LG spin-off. In traditional virtualization system, it usually takes from several minutes, maybe to tens of minutes to prepare the environment. Container spin-off, however, takes seconds, and often even less than a second. As an example, let's assume that you're integrating a performance testing part as a part of your CI chain. So Dockerized load generators are ready for use almost instantly. With Docker, you get less isolation comparing to the traditional virtualization system, since it's hosted. But compared to the traditional VMs, the containers are truly lightweight, and it's an excellent solution to short-living tasks. When you're working with dynamic resource allocation, it's reasonable to have a certain management tool for that, a certain layer for the management. The orchestrations are coming to manage the environment, providing an abstraction level for such virtualization. So we have several options currently available. Most of them are open source and free for usage. In 1255, we presented an API that helps to involve Dockerized Linux-based load generators in your CI/CD process. Though just before I demonstrate that, I'm glad to share that in the future versions, we plan to introduce the possibility to use Dockerized load generators as a regular load generator as part of Performance Center UI. It's just to use it just as a common load generator. And of course, we are going to introduce an integration with the orchestrator. Let's consider together a case where you wish to incorporate and automatically execute a performance test as part of your CI and CD process. To create a Dockerized load generator and add it to your PC server, assign them to a test, and then execute a load test. In this example, we are going to, in this demo session, in upcoming couple of minutes, we are going to go through the code that actually fulfill that flow, and then we will see how it actually executes. Just a second, I'm going to enter into a virtual machine in order to show you the code. Thank you very much for your patience. From the first glance, this code might seem a bit complicated, but believe me, it's not. After Oren introduction, after Oren introduced several REST code examples in details, it will be much easier to understand those examples as part of a flow. So let's dive into the code first. As we see our main function contains several functions. It's something that presented a flow. As I mentioned before, we need to load several parameters. We are going to review them. Then we are going to create a Dockerized load generators, logging into PC, add those Dockerized load generators to the Performance Center, execute a load test, wait till the completion of the test, and actually later we are going to remove, or let's say clean, or get back those resources to the private cloud. So the flow was pretty simple. In most of those cases were described in detail by Oren before, but let's start. First of all, we have several parameters to provide. So in order to connect to the performance center server, we need to provide a PC server name, a username, password, port, or Docker host, a number of Dockerized load generators that we'd like to spin off. Then, of course, we'd like to provide the duration for the time slot. So it's pretty simple, as you see. Let's go back to the flow. Okay, as you can already see that those parameters were grouped, pretty easy to read. We have Docker host related details, as we saw before in an input.txt file. Then we have several PC server and project details. Then we have details about the load test that we'd like to execute. And currently, let's dive into each of the functions, and let's see whether it's complicated or simple. So this is the first function. We're actually loading the parameters from the file. That's pretty straightforward. We're creating the dictionary and reading the input.txt file first, whatever we have here inside, and then we are going back to the main function. Currently, when all the needed details of our flow are loaded, we would like to spin off or create Dockerized load generators. So how that function looks like? As you see, again, the function is pretty light. Spin off Dockerized load generators, we need to construct a container, and for that we need to create a Docker command. A Dockerized load generator image is located on the Docker hub, and it's being retrieved by Docker command, of course. By default, Docker containers can make connection to the outside world. Don't forget that this is a virtualized system. That containers are actually shared the same host machine. So Docker containers can create a connection to the outside world, but the outside world cannot connect to the containers. For that, to let's say solve that issue, we must map ports for each created container. We have a parameter that creates that internal port, and of course we have for the communication, and we have a default port, a default load generator port. So as you see here, we are creating a container, we're building a command, and then we are creating, we executing that command for each of load generators. If we are going back to the input.txt file, we are asking to create 4 containers for that task. Let's go back here, and as you see, currently we are executing 4 containers. We're building those 4 containers, and then we are going back to the main function. Again, the function is pretty simple. It could be used as is, like copy paste to your own environment, and we can continue. After those load generators are created and available in the network, we are going to log in into Performance Center. This REST call had been reviewed already with Oren, and we are going to see this call again. Just sorry. Okay. So it's pretty much the same function that you previously see, except one simple difference. Here in that function, we are using an open source REST client that actually downloaded, or you can use your own REST client for that purpose. So we must encode group credentials in base 64, as Oren mentioned before, and we are retrieving the cookies from the response of the REST call. Those cookies are valuable, and we must use them to continue to the same session later on. Again, let's go back to the main function. After we actually logged in into PC, we have and we own the cookies. We are going to add the Dockerized load generators to PC admin. Okay, we generate an appropriate name for the Dockerized load generator. So the name format is Docker host name. As you can see here, the original name of the Docker machine, the hosting machine. Then we add a suffix and the appropriate port for the communication, as I mentioned before. The string, the building the REST call is pretty simple. Again, it is exactly as Oren described before. We're executing that call, we're sending that call to the performance center, and as a result, in response, we retrieving back the IDs of those load generators that were added to PC admin. When those load generators had been added to performance center, we are going to execute the test. Again, that was an example in Oren's presentation. The call is pretty simple. We are constructing again a REST call, including the test ID that we retrieved earlier from the input.txt file. So we have here test ID that we would like to execute, and of course the test instance. As when the run was executed, when the test actually was executed, as a part of the response, we are getting a run ID, and we would like to check the status of run ID later to wait till the test will be completed. Okay, again, just to remind, we loaded the parameters from the file, we create Dockerized load generators on the Docker hosting machine, we enter into Performance Center project, we added the hosts to Performance Center, and currently we're executing the load test. Then, since the load test has been executed with predefined run action or post-run action, we just need to wait till the constraint of post-run action is completed. When the post-run action is completed or is actually reached, we can get back to main function and clean all the Dockerized load generators that we previously created. What we can see in this function, we are checking the run state of that load test using the REST call. Let's assume that the post-run action had been reached, and then we are going to back to the main function, and we are going to remove the Dockerized load generators from the Docker machine, actually removing the Dockerized containers from the hosting machine, and then we are going to clean the PC as well. Here we are again, since we're owning the Dockerized load generators IDs, we can go to the Performance Center project admin, and we can remove the hosts from the Performance Center Just in a minute, we will see it's in a demo how it looks like from PC side, and I think it will be much more understood from here. So here we have Here we have a performance center administration module. Let's see how it looks like when we are invoking and adding a load generator. When we are invoking Dockerized load generators into PC. So as you see, again, let's start it again. Let's pause the presentation. Currently, we have no load generator machines available, just the controller inside the PC admin. Now let's go to the Linux machine, the Docker host machine, and let's check whether we have or not Dockerized containers there. As you see, we have no Docker containers on the machine. Currently, we are going to execute a command that creates those Docker containers. Just pay attention that those Docker as load generators will be created in a second. As you see, those hosts already were created and added to Performance Center admin. Let's see it first in Linux. As you see, currently we have 4 new Dockerized load generators freshly created in a Linux hosting machine. Let's go back to Performance Center and then refresh the list of the Dockerized load generators in Performance Center, and we see that, and we can see that those machines were successfully added to load test. Those 4 load generator machines that were added to our environment. Just pay attention to the name, as I previously mentioned. Sorry. Beg your pardon. Okay. Let's see again that part. I think it's very important to emphasize that those Dockerized load generators have been created in a second, and now we can see them. In our environment. Pay attention to the name. It consists from the original Docker hosting machine name. Then we have DKR and then the port number. Currently, as you see, we just initialized and executed the load test, and we are waiting till the test will be initialized, then it will be executed. As you see, the run state has been changed to running state. It again was checked using the REST call as that we saw previously. Currently, all our hosts are in a running state means that our test is using those Dockerized load generators. The test had been completed, and now we are removing those containers. First, we are removing those Dockerized load generators from the test from PC, and then we actually removing them from the Linux, from the Docker hosting machine. As you see, again, everything will clean. The machine get back to its initial state. Now we can see that in Performance Center as well. All of our load generators were successfully removed from Performance Center, and then more or less that's it. This is the demo. Again, just to remind that this demo, including the code, will be added to later on, and we are welcome to ask all questions in the forums or directly to us. I just want to emphasize several things. Again, first of all, the REST API reference, we have it in documentation. We have link including the examples. It could be it is public and could be accessed. The other thing, it's very important to emphasize, we have a Jenkins plugin available that could be seen. We just going here. Let me show you. Okay, great. As you see it now, it's publicly available. Again, Jenkins plugin, it's an open source. You can use it as is for your own needs. Another thing, it could be used as an excellent example, or let's say a set of examples, in case you would like to implement something custom for yourself. We can see that most of the needed functions are already implemented here. You can see the authenticate function here. You can see the stop run. You can see the start run. All those calls are implemented here. It could be copy paste with this or that customization into your own environment. I encourage you to enter here and to see how simple is that. In addition to the Jenkins plugin source code that you can learn, we started to publish a series of blogs that related to the REST API. The link of the blogs again will be shared with you. Those blogs will guide you step by step and to implement any examples of your REST API, starting from the very simple ones, including later on with the more complicated ones. Again, you are welcome to respond, to ask us any questions. And another thing is the REST API code that we published is a result of the will of our customers. Our customers asked us to implement or to publish the API in order to involve a performance center and performance testing as part of their own environments, or their own DevOps or CI/CD processes. And I'm encouraging you to send us your own requests, that will complete or will help your own needs in your own company.
Okay, so thank you very much, Oren and Albert. And before we finish, we'd like to invite you to our next webinar, which will be the Performance Center Tips and Tricks on January 16. Originally, it was planned for December 5, but we had to postpone it. So we apologize for that, but it will happen on January 16. If you are interested, you are invited to email us to plv_cost@microfocus.com, and we'll send you the invitation in 3 weeks from now. And that's it. We'll go over all today's questions and we'll send you the list with all the answers, in addition to the webinar recording and slide deck. Thank you very much for attending the webinar. We hope you found it interesting and beneficial. Have a great day, and thanks for joining.